Before watching this lecture, you should know the definition of a statement, a predicate, and an implication. Remember, an implication is a statement in the form if A, then B, which we typically write as A implies B. Here, A, the hypothesis, and B, the conclusion, are predicates, sentences with a free variable that becomes a statement when the variable is replaced by a specific value. An implication is then true unless you are able to find an X such that the hypothesis is true while the conclusion is false. X greater than 1 implies X greater than 0 is, for example, a true statement. Most statements in mathematics are implications, and sometimes the predicates that make up the implication can be quite complex. Here is a slightly more complex implication. If x is less than minus 2 or x is greater than 2, then x squared is greater than 4. The hypothesis of this implication consists of two predicates, x is less than minus 2 and x is greater than 2, combined using an OR. For more complex statements, it is sometimes useful to create a truth table, which we will now discuss. Consider first the implication, if A, then B. This implication contains two predicates, A and B. Once we have replaced the free variable with a particular value, then each predicate becomes a statement which may be either true or false. That means that we have 4 possible cases, and we consider these cases in a truth table. We create 2 columns, one for each predicate, and we create 4 rows. The 4 combinations are A is true and B is true, A is true while B is false, A is false while B is true, and finally A is false and B is false. For a simple implication such as x greater than 1 implies x greater than 0, if x is 0.5, then A is false while B is true, and we are on this row. Remember, an implication viewed as a predicate is false if the conclusion B is false and the hypothesis A is true. That is, the implication is false in this particular case. In all other cases, the implication is true. An implication viewed as a statement is true if it's true for all possible values of x. We can confirm that the implication x greater than 1 implies x greater than 0 is a true statement by considering various values for the free variable x. If x is less than or equal to 0, then both A and B are false and the implication is true. If x is greater than 0 but less than or equal to 1, then A is false while B is true and the implication is again true. If x is greater than 1, then A and B are both true and the implication is true. There is no value for x which will land us in the row which would make the implication false. On the other hand, consider the implication x greater than 0 implies x greater than 1. In this case, if x is equal to 0.5, then A is true while B is false, making the implication false. Given 2 predicates, A and B, I can form the implication A implies B. But I can also form the implication B implies A. This is a different implication with different truth values. We call this the converse of A implies B. For example, x greater than 0 implies x greater than 1 is the converse of x greater than 1 implies x greater than 0. It's not hard to figure out the truth value for the converse. It is false only in one case, and that is when the conclusion A is false while the hypothesis B is true. That is right here. In all other cases, the converse is true. In some cases, with 2 predicates, both the implication A implies B and the converse B implies A are true. For example, if A is the predicate x plus 1 equal to 4, and B is the predicate x is equal to 3, then the implication A implies B and the implication B implies A are both true. When an implication A implies B and its converse B implies A are both true, we say that A if and only if B. This is often abbreviated as A IFF B. We write this using an arrow pointing in both directions. A is equivalent to B, and we call this the equivalence of A and B. X plus 1 equal to 4 and x is equal to 3 are equivalent, while x greater than 0 and x greater than 1 are not. The truth table for an equivalence is then as follows. Both the implication and its converse must be true, and we see that the equivalence is true in these two cases, but false in these two cases. We also see that A is equivalent to B is true when A and B have the same truth values, either both true or both false. But the equivalence is false if A and B have different truth values. We have two more important ways of combining two statements. The first one is what's called the conjunction of two predicates or statements, A and B. A conjunction is true if both A and B are true, while it's false in all other cases. Next, we have the disjunction of two predicates or statements, A or B. A disjunction is true unless both A and B are false. Finally, we have the negation of a statement or a predicate, not A. Not A is true if A is false and vice versa.